Azam Khan is the co-founder and CEO of Trax.GD, developing an urban-scale symbiotic simulation and visualization platform. He founded the Symposium of Simulation for Architecture and Urban Design, SimAud, in 2010, is an adjunct professor of computer science at the University of Toronto, and has been the Velux guest professor at the Royal Danish Academy of Fine Arts, School of Architecture, and a member of the Technical Advisory Committee of CIFE at Stanford University, a research center for virtual design and construction. Azam received his Bachelor of Science and Master of Science in Computer Science at the University of Toronto, and his PhD in Computer Science at the University of Copenhagen. Azam was the Director of Complex Systems Research at Autodesk, where he led a multidisciplinary team of 25 people, including researchers, software developers, architects, and engineers. So for today's session, the topic of the session is goal-driven continuous improvement in the AECO. As project expectations increase, thereby raising the level of complexity and interacting requirements, our processes to achieve these goals must adapt and meet these demands. To address these issues, we present a conceptual process for continuous improvement that's explicitly goal-driven, so that computational methods can help measure progress and automatically recommend actions that maximize progress and minimize effort. So I'd like to hand it over now to Azam, and let's get this presentation started.
Thanks, Laura, and thanks to all the sponsors and the attendees for joining today. I'd like to add that we're also happy to, as it has on the screen here, join the Arab Entrepreneurship Program, and we look forward to working with the local and international Arab teams as well. Just a brief background about myself and a few relevant initiatives. First, I started Project Dasher just over 10 years ago. We've been working on various aspects of digital twins in buildings and outside of buildings as well ever since. In the center is SciDevs, which is an open source discrete event system simulation framework for simulating complex natural and artificial systems. And we've used that for a number of years for occupancy simulation projects. And as Laura mentioned, on the right is SimAud, the Symposium on Simulation for Architecture and Urban Design, which has become a leading research and practice conference that I co-founded with colleagues actually from Carleton University, also a short decade ago. And that'll be coming up May 25th, also as an online event. Over the past couple of decades, I've also had the great pleasure working in software, research, and management roles at a number of companies: ATI, now AMD, Microsoft, Adobe, Alias Research, Autodesk Research, and now Trax.GD. And all my research activities can be found at azamkhan.com. So today, I'd like to introduce a new concept for digital twins in AEC and operations, which I call goals. I should have put new in quotes there, because of course nothing's new. There's been research in visual code compliance for some years ago, and this is really about bringing that forward into practice now. So goals as a new concept sounds simple enough, but I want to differentiate the traditional tactical digital twin goals, like understanding building performance or predicting issues in mechanical systems, from strategic goals that could drive actions to make a building better than it ever was. We'd like to go beyond continuous commissioning to continuous improvement. As you can see, goals come in a variety of shapes, sizes, and colors. This is actually the symbol that represents the United Nations Sustainable Development Goals, if you're not familiar with it. There are 17 of these goals, of the global goals the United Nations has put forward for sustainable development. There's things like no poverty, gender equality, clean water and sanitation, climate action, and clean energy. Our focus at Trax.GD, and I'm sure at CanBIM, the CanBIM community more generally, is the goal for sustainable cities and communities, which is goal 11 there. Goals could mean all kinds of things, and of course, including our normal tactical goals. We can organize them hierarchically from the most local and specific at the bottom, and moving up towards the most global set of goals at the top. Building codes have national scope, but also local regional versions, of course. Design goals above that, like LEED, BREEAM, and so on, are at the building level. Operations goals, like the WELL standard or LEED operations and maintenance, have a broader scope over time as well as space. The operations of a building exists in the context of the city scale, where goals apply like the ISO Resilient Cities or the ISO Smart Cities standards. And above that, we have societal goals like the Declaration of Human Rights, and ultimately including environmental goals. On top of that, on the top of the human goals, there's the United Nations Sustainable Development Goals, or the SDGs. In terms of IoT, things have evolved bottom up. A great set of organizing principles for digital twin features and properties are the Gemini principles that came out of the UK government recently, working towards their proposal for a national level digital twin. Just zooming in here a bit, at the bottom we can see inputs to the digital twin like SCADA systems, GPS, GIS and BIM, control systems, and more. Then we have 3 layers labeled on the left side there. You can see data management, sense making, and decision making. And the data value increases as we go upward, and learning comes back down to improve decisions. But there's still a gap between digital twin and the strategic goals. The question that we ask ourselves here is, how do we get there? There's a bit of a hint down in the corner with this process diagram. The problem is that short-term goals are bottom-up, while long-term goals come top-down. And digital twin is somewhere in the middle, but it's not the whole story. The digital twin is really a piece in a bigger continuous improvement puzzle. To help us think through this, we borrow the concepts of process modeling and automation and optimization from the manufacturing industry. So why process, you might ask? It's really to address complexity and support automation. Process management has really been absent in AEC projects, but is standard practice in manufacturing efforts. The custom nature of every AEC project goes against kind of the whole idea of process management, because process management is about standardization. Complexity also, of course, is a cause of, as each project involves hundreds of companies and thousands of people due to the lack of automation, but also the distribution of disciplines and expertise across all these different people and companies that are required to complete one of these large construction projects. On the other hand, process management makes everything in a project explicit, exposing risk and supporting informed decision making. Why continuous improvement? It's really to integrate change. In AEC, of course, the large scope and long duration of the projects means that we absolutely know there will be changes, some small, some not so small. The question is, how can we learn from change? Can there be changes that make things better? The manufacturing industry has successful examples, the Kaizen philosophy of adopting behaviors to ensure that process improvements are both surfaced, discovered, and integrated into their process. This supports the concept of a learning organization where growth in knowledge is central to the success of their business. However, in AEC, we often start from a blank page. And finally, why goal-driven? And that's where we believe that we can really include and leverage computation. By making project goals explicit, we can use automation to compare the current state to the expected state, to reveal opportunities to make corrections and improvements continuously on an ongoing basis. Goals help with the elicitation and the elaboration of requirements, the resolution of conflicts, the clarification of decisions, and all these things can actually drive design and implementation, hopefully. So a goal-driven continuous improvement process is the new concept that we're proposing to take digital twins to the next level. This is exactly our mission at Trax.GD, and hopefully everyone's mission in some shape or form. I can ground this with an example. We've been working with Niagara Health and Stantec on the process of designing their processes. Niagara Health, as a system, has 5 hospitals and healthcare centers in the greater Niagara region, and now they've embarked on their 6th facility, a new hospital, the South Niagara Hospital Project. To create a new hospital is a major undertaking, of course, and to help standardize the process, the Ministry of Health has developed a capital planning process framework with 6 major stages. Each stage has a checklist of all the items that must be submitted and reviewed and then approved. But the complexity of preparing these items led the team there to develop a roadmap that would make the process and the interrelationship and requirements dependencies between the tasks explicit. The result is an impressive 240 square feet of tasks, approvals, reviews, artifacts, and deliverables that really goes across the entire room. And it's hard to, it's super impressive once you see this up on the wall when you enter the room. But just to give you a better idea of what level of complexity is involved in all of these things, let me zoom into just a small portion to give you a better sense of what the roadmap contains. So in this little area here, you can see some of the linkages and sticky notes representing different processes and so on. And based on the links and the notes, you can see that this process is not really straightforward. Over time, as the design process changes, it becomes even more complicated and more difficult, of course, to actually draw this. You can see a number of joiners and jumpers there to other locations. And these little sticky notes, they're not just little tasks. Some of them are entire large consulting projects that result in like a 400-page report. So a lot of these can be quite significant tasks on their own, involving their own schedules and their own requirements and so on. Zooming back out, you might ask, where do I fit in? Where does my project fit into this kind of a process? And it's hard to explain the whole thing, and I certainly couldn't. But we can highlight a few places where some of these things would normally play in. At some point, there's a commitment to implementing, in this case, actually the WELL standard. And they strive to be the first hospital in Canada that adheres to the WELL standard. VIM is required, some emergency room simulation at some point, the creation of an as-built model, maybe digital twin could be scheduled. And the key advantage of pulling back to this process level is exactly that you can see where all these artifacts come in, how they relate to each other, what the inputs are to even starting one of these processes, and what depends on them afterward. You can see the The large stage there to the right is actually double width, and that's the actual construction phase of of the hospital project. And this is a generic template, so this is not for their specific hospital. This is just to represent the Ministry of Health process. Oh, slide not advancing. Okay, hopefully that you're seeing that. In addition to the normal artifacts, I've included just the goals here. So, and I'm just using the SDG symbol there to represent goals. This project doesn't necessarily directly relate to those goals, but goals in general can be expressed together and are expressed in different ways, including WELL standard, coming before even the BIM and so on as a set of goals. So some will be high-level goals, like adherence to certain standards. Some will be low-level goals, detailed goals that are proposed and agreed upon in the scope as the whole process continues through. To help turn the roadmap into a living document, we've developed a process authoring and analysis tool that encodes the hospital capital planning process schema, of which defines the scope of what's possible to represent. And what I'm showing here is not all of the nodes of the complete wall, but just stage 2. And it's in a specific layout. We have the advantage, of course, in the digital version to have different representations, but this is a specific layout designed to reveal bottlenecks and show critical paths. From here, we could also do other things like generate a schedule and perform a number of other transformations on the data and analytics on the process itself. So that was the top-down overall process that includes the digital twin. Getting back to the bottom-up process, we have the familiar things like sensors, the GIS and BIM, asset data, analytics, machine learning, and decision support. And all of these are, to support the maintenance and planning processes. And the digital twin, of course, still serves all of those kinds of things. Here in our tool, for example, I'm just showing a couple of the Carleton University buildings here. And if we select Richcraft Hall, we can load the IFC in the Trax viewer and see the time of day, for example, in the timeline, and some of the components on the right in the browser. We can, in the model browser, we can step through the different floors and so on to see the internal structure. And then I have a little video here that I'll just play that shows turning the model, selecting a floor, showing the sensor dots, hovering, turning on the sensor dots, hovering over them and seeing the spark lines of recent values. And we can enable the heat map view to visualize the temperature of the room containing the sensors. And while we might be used to seeing these kinds of things in a digital twin, even here we're still missing the goals, the expression of the goals, and a comparison of the goals to the current state. And this is where the, in quotes, new concept comes in. The key question is, how do we express the goals in a continuous improvement process? Again, so that not just the digital twin can get better, but the physical twin can also improve over time. So in zooming out to the broader process, we want to begin to encode the standards that relate to projects at different scales. Here back in the software, you can see we have enumerated some of the standards that we're looking at. Including the SDGs as the most general and broad one, the ISO standards, and so on. If we select the WELL standard, we can go into that one. And then there's a generic roadmap for the general WELL standard, and it calls on a number of subgraphs one for each of the 10 well standard concepts, the concepts like air, water, nourishment, and so on. If we click on the general roadmap, we can see the requirements graph here on the left, together with the Python code that aggregates the final step of the certification evaluation. So you can imagine running one of these graphs inside of the hospital process, the larger process, and as both the big inputs would be both the business commitment early on to decide which of these key concepts they want to support. I mean, there's in the well standard, if you're familiar with it, there's required elements in each one of these subgraphs, but in addition to that, there's the optional ones. And so by spreading it throughout the larger process, we can see when business would have to commit to supporting some of these things, when they would be developed in the context of a specific design, and then later when they would actually evaluate ideally in an automated way, run the evaluation and see how that particular design is performing. You can imagine also if the design is a generative design process, that you could have the output of this well standard evaluation feedback as a metric to alter the design until this particular goal, and all of the other project goals are met. The subgraphs, the input nodes here are all the 10 concepts that are the outside graphs there, and they would all feed into the calculation of the overall evaluation. The transformative benefits to encoding goals and making them explicit is that there's quite a bit you can do with that. The idea of encoding goals is that once they're explicit, they can become part of a continuous improvement process, and this enables automation. Automation has been a challenge in AEC and construction for some time, but you know, as we continue to expand throughout the entire process, hopefully enough single points across that process will become automated or have a central data set, so that this will enable the entire raising the bar for everyone. By showing the process flow to key stakeholders also, they can better understand when commitments need to be made and when they need to be implemented and validated. So you can imagine being a stakeholder, and there's a variety of them in this process, for example, governance or finance or the design team, of course, and so on. And they would all be able to see what they're waiting on, what their work depends on, and what work depends on them making those decisions or completing some work, to see what the downstream effect is. So by showing the process flow to the key stakeholders, we can see the key benefits and commitments, and when everything needs to happen to have a coordinated result, and also expose, of course, when delays and other risks might happen. We can also express the design intent in this way. So, of course, many projects start out with a lofty design intent goal, and we want you know, our projects to be great, but a lot of things happen along the way, and this, as I mentioned earlier, change is part of AEC. Change requests are part of that, and so as things change, we lose we can lose the original design intent. However, if it is expressed and captured in a larger process, we can, on an ongoing basis, actually report what we have lost or ideally, if a process gets better, what we've gained, and then show that also later in the digital twin. So that'll reveal what needs to be done, maybe even during design time and certainly during operations time. But ideally, that will be the mechanism for getting the feedback loop to have a continuous improvement process. So finally, and most importantly, we can support more ambitious goals over time. Standards themselves are not static things, of course. So LEED has been through a number of versions. I think it's above version 4 now. The WELL standard also is on their version 2. So these things, and of course building codes, continue to evolve. So these things are also moving targets. So it'd be nice to, on an ongoing basis, understand what has changed in the environment outside of your own project that actually relates to your project. And of course, as these goals become typically more ambitious over time, we need to do things to improve our assets. As environmental requirements also become more ambitious and move from let's say design goals to requirements, that will also ideally expose where in a project there's opportunities, and even include the costing and so on to make these things happen. And that will help in the planning process, the financing process, and so on, to be able to accommodate these kinds of changes. And finally, with of course, now with biological concerns, we're all presenting here from home, becoming highly relevant to everyone. Hopefully, that impact has also sunken into the stakeholders to see the benefits of doing something like this, or actually not even whether they see them or not, maybe being required to respond to changing conditions, as we've seen now with COVID-19, so that they can improve both new and existing aspects of the built environment. And I think that covers it. I want to thank everybody again for their time and their attending the talk, and I'm happy to continue talking, of course, but love to have a conversation with everyone. So please let me know if you have any thoughts about these things. That'd be great. I'd like myself to learn from you as well. Thank you.
Thanks, Azam. That was a really great presentation. For anyone, if you have a question, feel free to ask it in the Q&A. We don't have any current questions at the moment. But I guess one question that I have for you is, thinking about the digital twin, how could we apply this to kind of like a regional or even a national scale?
Yeah, that's a good question. Like the generative design process, if you're familiar with that, it involves solving a slightly more general problem than just the design at hand. So there's some overhead in doing a generative design project, for example, where you try to solve a more general problem, and then you have parameters, enough let's say extra space, so the parameters can be varied enough to generate a variety of designs rich enough so that the computer can help you find other designs that you may not have thought of, or combinations of features in a design that would have been difficult or impossible to come to yourself. And so the advantage of having a computational process really will only pay back if there's that level of complexity in the first place. So in a similar way, by encoding a larger process around what we would typically include in the AEC domain, to include the full process, but also the life cycle, and of course making it ongoing, is overhead. So it's not going to be free. On the other hand, the larger a project, larger and more complex a project becomes, the more payback there will be from implementing any of these kinds of things. So the payback will far exceed the investment if we move to more complex projects like a hospital, for example, and often a hospital environment. There are typically other buildings related for long-term care or others, testing facilities close by and things like that. So as we move to multi-building scale, all of these things become more helpful, and having the computer help in managing all of these things and reporting on potential opportunities for improvements is helpful. And then moving up to even the larger campus scale, for example, at the Carleton campus, we'd like to have the full campus project there. We can really start to move the dialogue from of the smart cities, for example, to a practical implementation of these things. But that increased level of complexity really it will benefit from encoding standards and encoding things outside of the normal metadata we have in a project. And so as that continues to grow up in scale beyond a campus level to a city scale, or to even, of course, a regional or national scale, you'd really have to do something like this. Otherwise, we have what we have today, which is these standards that are difficult to interpret, and also become so abstract that they're hard to make concrete and implement.
All right, thank you. Are there any other questions from the audience right now? I guess one kind of practical question is, when can everyone kind of get their hands on this tool? Is it available to the public right now?
Not currently. This is still a work in progress. We'd like to work with a number of people to help us develop this tool and this process. Of course, because of that variety, it's of different stakeholders and different types of things. There's a lot of interesting things that can be done, including different node types for automated approvals, embedded electronic approvals, and especially the scheduling, automated scheduling part we're very interested in. So although it's not publicly available, I'd love for people to reach out and connect with me so we can really explore how this kind of a system could really save and improve outcomes significantly.
Well, just speaking from Carleton, I think we're really excited to be working with you on this and kind of sharing our models with you.
Yeah, same here. I look forward to really showing that as a great, that'll be a great showcase of moving to these larger scales.